Dark and delusional, dark and delusional, dark and delusional, dark and delusional. Welcome to another day, another night, another dollar at what we call dark and delusional because we can't spell and we don't like the word and anyway, so we went with the letter N. Tonight we have a special episode, a special guest, and before I get started, I want to say this is the most anticipated episode of 2025.
I am so excited right now.
So far.
I don't know why that is.
You don't know why that is. It's because you chose a topic that
At
I
random.
thought I would never talk about in my life ever.
Yeah.
That is why. That is why. We built this episode up. We've been hyping each other up, excited for this, and I'm happy that you're here with us. My special guest for tonight. Go ahead.
Oh, happy to be here. I'm going by Schlurmple.
Perfect. I was about to say introduce yourself. You already know how this works. This is great. So before we get into it, please state the topic and why you chose this particular topic, because as far as I know, you don't really deal with this topic on a daily basis.
We're talking about ball bearings today. I chose it because I picked a random ass thing, and it's the first thing I thought of.
So I guess first question from my side, why were you thinking about ball bearings?
Yeah, weren't we gaming? Were we playing AoE or something?
Yeah, I think so. I was just like, oh, what's the most irrelevant thing I can think of?
But it is the most relevant thing in the world.
Yeah.
I think we were actually playing Smash Bros.
You're right. Yeah,
Oh,
we were
yeah.
playing Smash Bros.
I think we're doing Smash / Triforce.
Oh
Right.
yeah,
Zelda.
Zelda.
the emulator.
Yeah, we were playing
Mhm.
Zelda too. Yep, that's
So-
it.
I have a legal copy, by the way. It's all legal.
I have a
Yes.
copy as well, so it's
And
double
Praise
legal.
Nintendo.
And before we get going on ball bearings, I want to say if you ever want to test how good of friends you really are with someone, you should play Zelda and the Four Swords.
And throw them off a cliff or plant a bomb in their face
It must
and
be we're
see
not
how
very
they
good
react.
friends then. I mean,
Oh,
the host.
for once it's anonymous podcaster number 3 who's fucking up this shit. Anyway,
Yeah, well,
what did you want to talk about ball bearings? Or are you just bringing this topic to the table?
I just think they're neat.
You think you're neat? They are neat.
they are pretty neat. Let's get into it then. Where would you like to start, Schlurmple?
I was under the misinformed understanding that they were like the little metal beads and things. But actually, I think it refers to a whole like device that the beads are all but as part of.
Indeed.
That is true. I guess since we're there, we should define what a ball bearing is.
Piemonger, you want to take that away?
So I mean, I don't know the exact definition, but a bearing is used to reduce friction between something that's rotating to something that's stable, right? Typically. There's other types of bearings, but that's the bearing that we think of. A ball bearing utilizes, you guessed it, balls to reduce the coefficient of friction between those two pieces. So essentially, wherever there is something that is rotating, which is a lot of things, there is a bearing involved. There's a lot of different kinds of bearings, and ball bearings, I believe, are one of the most common.
It's actually one of the most ancient too. So the research I did, I totally spent all week researching this subject matter. You guys know how like supposedly when the Egyptians were building the pyramids and they supposedly used like a bunch of logs to roll the gigantic stone block. So that is like technically credited as being like the first ball bearing.
Mm-hmm.
That is,
Interesting.
they accredit that to being a ball bearing, like a primitive ball bearing.
We would now call those roller bearings.
That is true.
Yes,
that is true.
correct.
But very similar. They were the earliest version because people knew, hey, like this stuff rolls. Let's throw it under something heavy, get stuff places.
Well, I mean, it's
Ooh, that
obviously
reminds me.
it's a technology that we don't really have a measure of because it degraded. Because like they used all wood originally, like they made balls out of wood. Like they found this ball bearing in 80 BC. It was a Roman ball bearing and came off a ship. and it was in the table. It was used for like this rotating table that they had in their ship. So if it was around in 80 BC, it was probably other places, but wood doesn't hold up good. I mean, as opposed to time, really.
That is true.
I mean, it is interesting. I mean, if you think about the concept, right, rolling something, it's not that dissimilar to like the wheel to a certain extent. I mean, obviously how it functions is slightly different, but you're reducing that coefficient of friction with having something that rolls. So it's pretty similar concept, just very different execution.
It really is. Did anybody else go to the Wikipedia page for ball bearings before this episode?
Very briefly, yeah.
Did you
No.
see on that Wikipedia page they have a GIF or whatever that is showing you how ball bearings work?
I did not see that. That would have been very helpful.
Yeah, no. So there's a live picture on the website that show you how ball bearings work on that Wikipedia page. According to that picture diagram, the ball bearings do not rotate within the mechanism the way I thought they did prior to seeing that.
They have like a figure to hold them in place, yeah.
Yeah, no. Well, yeah, not the part that they fold in place, but the little balls inside, they're spinning. They're not spinning like in my brain I was thinking they'd be like spinning like a planet spins on their axis, you know. But the balls actually roll from like a diagonal towards the center of the rotation. It just was interesting to me. I didn't think they spun like that within the mechanism.
Well, I mean, and speaking of the mechanism itself, right? If we're just going to start talking about ball bearings specifically, there's a lot of different designs to ball bearings, right? You can have more, I mean, I don't know all the technical terms, but you can have them more flat. You can have a race that is angled. You can have multiple sets of balls on either side, right? All to basically tailor the device to different loading conditions. So, I mean, I guess if we're on the topic of loading conditions, what direction do you think these ball bearings are loaded in, guys?
What do you mean by loaded? Like when they're making it?
No, so in service, right? You
Omni?
install, yeah. So you install this ball bearing. Let's just say on an axle shaft, right? Like in our cars, or a wheel bearing, right?
Yeah.
So they're loaded radially, right? It's taking the load of the car from the wheel, right, as it goes down the road. But ball bearings can actually take loads axially through the shaft as well, especially depending on how they're designed. So it can take
Yeah.
both of those loads at the same time. And other bearings aren't really able to do that very well. Like, for example, like roller bearings, from my understanding, you know, they're kind of like the logs that the ancient Egyptians used to use. They can't take a side force as well as, say, you know, a ball bearing does.
Is that due
and
to
that's
the
actually-
shape? Is that due to the shape of the ball bearing itself being a
It's-
sphere? It's able to take loads from both sides at the same time.
Yeah,
Yeah,
I believe
it's directional. Yeah.
Yeah.
The balls have like one point of contact, whereas the rollers have a whole line of contact, and that kind of doesn't shift inward the same way.
That makes sense.
It's the ancient Egyptians. They were able to use all those, large trees and stuff like that. And even actually the largest, one of the heaviest objects to be moved by people without the use of machinery was the thunderstone, and they used logs, but they couldn't exactly make it. They couldn't move directions very easily, right? Because it's a one-directional
Yeah.
thing.
Right. Once you're
That's where
set
ball
up,
bearings come into play.
it's hard to turn. I would imagine like trying to even turn something like that, you pretty much just risk what you're moving rolling off your tracks and ruining all your hard work.
Right.
Yeah, but
And because of that, they had to really plan out the path of how they were going to take these things. Not
Yeah.
easy to change course.
they probably had to make roads exclusively for this.
Maybe some roads that still exist today were just seriously ball bearing paths that they already put in the work to clear, and then they later became trading routes.
All ball bearings lead to Rome.
All ball bearings lead to Rome. I have some examples here. If you guys want some examples, some of them were not. I did not think had ball bearings in them. I got a computer fan.
Mm-hmm.
Mm-hmm.
Yes.
They're very prominent in horology, which is not the study of horrors. It's the study of time, like making
knew you were
clocks
gonna
and
bring
shit
that up
like
at
that.
some point.
I had to.
Oh yeah, that was one of the examples that blew my mind. Like, oh, so and so made a watch piece or
Yeah,
something
with like
little.
super
Yeah.
super tiny ball bearings. Like the ball
that's a-
bearings in that watch are tiny, very tiny.
And that is kind of the crazy thing. I mean, these things, like, because there's so many different applications for anything that rotates, right? Like, you get down to the tiniest little watch interface, up to the point where you can the biggest ball bearings that currently exist. There's one that's 30 meters across, which
30 meters across.
that's not freedom units, but that's okay.
We're talking like roughly 90 freedom units. Yeah.
Yeah, right.
We're
90
talking like
feet
80,
across for
87 feet.
10,000
87 feet or something like that is what that
yeah,
comes
for a
out to.
10,000 ton capacity crane. So like
10,000
tiny little smooth
so
adjustments to giant, massive, movements of serious material. So
not to
Yeah,
mention
no.
that there always has to be more than one ball in the ball bearing, correct? Like
You have to have a
especially
lot.
yeah, you have to have enough to fill the fucking rim pretty much, right?
Well,
It
oh,
has
you
to be
want to
evenly distributed, I think.
That's right.
exactly.
That's the most
exactly.
important part.
Yep. It's all about the loading, guys, right? Because I mean, I can maybe later I can talk about some of the failure mechanisms, but it's all about the loading, right? You start loading one ball more than the others, and then you got a real problem on your hands.
Right, so you're just trying to split the mass evenly.
Yeah, but
And
like the thing is though, like, okay, if you look at they're not necessarily loaded all the same at the same time, right? So if you think about like a ball bearing in your car, like a wheel bearing, the the top is being loaded, right? The top of the ball bearing because it's sitting on its own weight. But then those can spin around an axis and the weight kind of gets distributed that way
right, but more of it's
as
like
it rotates.
it's more freeing up. Like it's not. It seems like the most essential function of the ball bearing is to reduce friction,
Absolutely,
reduce
100%.
resistance. So by spreading around the mass, you're essentially only able to do that because the friction in place isn't there, and that's what it makes sense in my head about.
So you're reducing the friction, right?
Right.
So if you didn't have ball bearings equidistantly spaced, or at least spaced throughout the bearing race or whatever you want to call it, you'd have a spot where if you're missing a ball bearing, well, it isn't going to roll there the same way. The friction will increase, and then that will destroy your system very quickly, especially depending on the loads and how fast you're going.
Dude,
Right?
honestly, so let's not forget that. I definitely want to come back to covering failure mechanisms with this because I just really did research on ball bearings. I wasn't really thinking about, them failing or why they would fail.
Yeah,
Well, if
and
they
that's
fail, it's catastrophe.
Yes. Running through the examples, they're used a lot in aerospace and, like, obviously, if we use them in cars. Oh, 1 second, guys. 1 second.
Ooh, an intermission.
Intermission.
What's great is, anyone that listens to this someday, that they might have thought that we were joking at first, that we were going to do a podcast about ball bearings, but here we are, like 20 minutes in.
Mhm.
If you ever doubted
So,
me,
take
you can go
that.
straight to hell.
That's right. Take that, listener. You
it's-
idiot. You thought we
it's
weren't going to
insane.
actually do a podcast about ball bearings.
Ye of little faith.
It's insane how interesting they actually are. I mean, there are people out there that their entire engineers, their entire career is devoted to, either making or designing these things. And there are so many varieties. It's honestly insane, right?
Mhm.
It's impressive, right? And we could do multiple series, like multiple shows
Yeah.
on different kinds of ball bearings, right? Or different
Yes.
types of bearings. Not that I'm going to say that we will, but it is actually pretty cool in terms of mechanical device, right?
Hey,
Yes.
our host has always maintained that we don't really care what the audience thinks. We don't want them to like, we don't want them to subscribe, and we definitely don't want them to comment. So
No, they
You're
You know,
here. You
in that
worship what we
vision-
say. You do. You think what we want you to think.
And in that vision, we might have other podcasts about different types of mechanical instruments. I think there's some really cool ones that we could do too.
Oh man, you're speaking my language.
I mean, when there's a will, there's a way. So we'll figure it out. Now we just wait awkwardly for the host to get back.
What's fucking new though? Let's be honest. Oh wait, can I say that word in this
Always
podcast? That can get blurred out. You know.
No, we
that's
could-
up
we
to
could say
the host, I think.
I think we could say
Damn.
fuck.
I hope so.
Fuck.
Fucking hope so.
Hey, I will say, I don't know if this is standard across industry, but working in a metallurgy lab, a met lab, we fucking swear like sailors. And it's like honestly really unprofessional, but I feel like that's consistent across the board.
I
I don't know why.
Oh.
I don't know why.
Dude,
I think people
Meth
that
lab.
are
I thought
in-
you worked in a meth lab.
Oh, yeah, I don't, sadly. That might be a little more lucrative. Yeah, no, I work in a materials lab.
I think people that are in the technical spaces or in like the scientific spaces, first of all, it gets really dark with the humor. I'm not sure why. Probably because you have to. It just takes a certain type of person to be working in like a closed, building all the time without any natural sunlight.
Mhm.
But on the bright side, you're not on a watch list and can still buy cough syrup.
That's right. Yes.
Wait, you guys can buy cough syrup? Fuck, they're on to me.
Yeah,
They
there we
haven't caught me yet.
go.
They have
No,
not
I
caught
think-
me
My
yet.
headphone.
I think across all industries, everyone swears.
Yeah, you just gotta keep it out of the
Maybe-
business meetings. though.
maybe not
Not
like
elementary teachers.
well, like yes, okay, yes, but
When
like
they're at work.
okay, when they are not customer facing, geez, when they're not facing their students, I'm thinking customer service.
Well, that really is their customer. I mean, let's be honest. It is
yeah,
the students, or at least the parents of the students.
All right.
yeah. When
But
they're in
we-
their lunch breaks, they'll start swearing. But anyways, we're getting
Fuck
off
that.
topic.
Fuck
the host
that.
was gone. The host was gone.
It's
We
all
got off
gone.
topic.
Chaos. Anyways, what was I saying? Let's see here. Obviously, a yo-yo is a good example of ball bearings.
I was thinking skateboards because like that
Skateboards
was the
are
biggest.
skateboard
yes.
was on this list. Yeah, skateboards. Pretty much the skateboard
the
only
bearings
exists.
were like the shit. It's like, oh, check out
Right.
my new wheels, man. I got
Look at my look at my
got the new
deck.
ball bearing, man.
Back when kids
I did
went
see some
outside.
skateboard stuff looking into this, but it was actually kind of surprisingly hard to see a diagram of how like the forces work.
Mm-hmm.
So I now know how to replace skateboard wheels.
that might come in useful.
I
one
will
day.
say, speaking of replacing ball bearings, I have replaced a set in my sand rail, and it was kind of a fun experience. You have to tap the bearing out. You have to make sure it seats right. If it's misaligned, it fails very quickly. I mean, it's interesting. It's very technical. Like it's very precise. And I think that's the big thing to get with ball bearings is that everything is precision. Everything has to be precise, and alignment and dimensions mean everything.
Because
Well,
otherwise, you're going to take something
nowadays-
that takes the friction out and then add a point of failure with a lot of friction in it.
Mhm. Absolutely.
At those points of friction are why things literally can blow up, because you take rotational energy and you slightly, you make a slight diversion to how it is moving, and all that kinetic
Yes.
energy just goes into one point. And that is why there's very cool videos
Yes.
on YouTube of air turbines just exploding,
Red glowing.
way
Yep.
up there, hanging in the wind because
Yeah.
their bearings fail. So kind of cool.
Yeah, like in general, for like a lot of like mechanical devices, in the perspective of, like a failure analysis, right? Misalignment can create a lot of problems, and I've seen that a lot, right? So it's always good when you're assembling it that you're within tolerances, right? Because if you're without those tolerances, right, you're out of those tolerances and you're misaligned. Like you said, the loading profile changes and the device does not work the way that you want it to. So it's just
to
super
be
critical.
clear, I wanted to put out that Piemonger used to work I believe you used to work in a failure analysis lab. Correct me
Yeah,
if I'm wrong.
I get to watch from a distance now, but yes, and I still try to get involved. I still read the reports.
While you were there, did you ever work on anything that had ball bearings in it?
So specifically, no, sadly. But there were some instances where ball bearings were a topic, and that's why I want to talk about some of the failure mechanisms and the general metallurgy, because it is a little bit interesting.
I agree with that, but we're gonna run through these examples first.
Sure.
Let's hash out everything about the ball bearing before we talk about how shitty the materials we use for the ball bearing is.
Ooh. Those are
Well,
fighting words. Those are fighting words. We use good materials.
Oh Jesus! Oh, okay. Well, you save them. We'll have a debate at the end about the materials used, and I won't know anything. Anyway, fidget spinner made millions and millions of dollars, and that's essentially like just ball bearings with a piece of plastic. Certain types of pumps use ball bearings, which I think is interesting. Centrifugal pumps.
Yep.
I don't know how that pump works. I can't picture it in my head. I didn't do no research on it. If anybody knows, please say what a centrifugal pump is.
Centrifugal pump?
Yeah, sure. Whatever.
No, he's got it right. It's
Yeah.
It had a U in it. It had a U in it, so I assumed it
I'm
was
stupid.
pronounced.
I'm sorry.
Yes.
It's probably because it spins. Like
Yeah,
everything else with
that's
ball bearings.
literally the thing. So it's moving. Yeah, it's just moving
Like
mass around in a circular motion, and then those are kind of weird because if I remember correctly, they're actually drawing the material through the center, if I'm not mistaken. Well, I'm gonna look it up right now because we do it live.
Maybe no, it would make sense actually. It's probably got like a bit of a turbine mechanism, and the ball bearings are seated to handle the friction from the turbine. You know what I mean?
You're drawing stuff. It's spinning on an axis really fast, right? And it's moving things outward radially,
Mhm.
and then the suction is drawing it through the center. So it's going through this. It's going through the center, and then it's getting pushed out to the edges, and then the edges is where you'd have the the tubing or whatever that is going to go off to wherever you're trying to pump stuff. So that's how it's actually really cool. My current job, I deal with a lot of those type of pumps because they're
like
very
the
nice.
sump pumps
Correct
too.
me if I'm
Yes.
wrong, anonymous podcast number 3, but you cook crack for a living. That's correct.
That would be correct. Yes.
Okay.
I mean, I don't like to call it crack. It's
I know you call it something fancier like crocodile or something, but
yeah.
Yeah,
dabble.
I used to make some drugs too, but now I've moved on.
But did you use ball bearings while making the
No,
drugs?
I used hamster ovaries.
Oh, that is really specific.
Are you being legit
I am
here?
being legit,
minute,
actually.
wait a minute.
You're being.
That's a topic for another day. Come
gotta
on,
use
ball
white
bearings,
ass.
people.
Someone throw
Ball
that in.
bearings.
Someone throw that into the website topic board, please. Or
Oh, come
when
on.
I'm editing this, I will. When I hear hamster ovaries, it's just gonna trigger
It
me.
used to be breast cancer cells. But
Anyway,
What? Okay, moving
another
on.
time. So, because I'm not done with these centrifugal pumps now that we brought them up, because I didn't even think to talk about this. But
What you really mean is because we went off topic, you had enough time to read up on the centrifugal
Yes.
pump.
well, that too. But
What's the advantage of having it do a centrifuge just doing it directly?
Yeah, well, what is it for pumping? Like, is it for pumping a particular?
Liquid.
Yeah,
big
liquid.
thing is,
but I
big
mean,
thing
is
is
it
just water?
it's
For example,
just water? Okay.
boiler feed water. It's so you don't have to worry about cavitation. I think is part of the problem, right? Because that could cause a lot of problems.
So
if you're not-
backflow then?
Yes. No. So cavitation gets kind of tricky, but
Yeah, there's like peristaltic pumps. There's also diaphragmatic pumps too.
Yeah, I have most of my we use rotary pumps and diaphragm pumps at work.
Yeah.
I've never seen a rotary or a centrifugal pump, but we do have centrifuges at work that we use, which those
Yeah.
probably have bearings as well.
Well,
Oh,
and
yeah.
the centrifugal. Sometimes a lot of these pumps, and I believe the centrifugal pumps as well. It gets kind of tricky because not only do you have to, have the bearings in there, but you have to have kind of like a filler material on the other side. I can't remember exactly what it's called, but some pumps will actually, backfill their mechanism with another liquid, for example, if it's moving liquid, which is kind of interesting. So all that has to be taken into account when you're getting these bearings set in. And again, if the bearing fails, then then the pump's gonna blow up. So it's
Yeah.
very important to get
Yeah,
those. And
I think that's a good illustration of just how much force these ball bearing technology takes off what it's trying to do. You
and
know,
if you don't have bearings that are able to hold up, you're not going to have pumps that are going to work properly. If you don't have pumps that work properly, you have no water pressure, no way to move liquids around, no way to keep your basement from flooding and things like that, depending on what the kind of pump is being used. So
Yeah.
it things fall apart really quickly if that is the failure point. And you can do crazy cool things because bearings allow you to go beyond the tolerances of materials by themselves, just physical motions. So
I thought it was interesting that kind of like how gears like turn one kind of motion into another kind of motion. You turn what would normally be scraping or like rubbing into or dragging into like a gentle glide.
yeah,
that is honestly really fascinating to think about.
so it's very important
Who do you guys
for modern
think?
society.
Yeah.
Speaking, I'm just a guest here.
No, I would say the cool part is like the amount of progress bearings have gone through where motors and pumps can last hours and hours and hours under heavy load for a long time.
Yeah, something else that's really interesting, and I didn't know about this until I started working in an industrial environment, but like you can check on how bearings and pumps are working by measuring the frequencies that the pumps are giving off.
Yeah, the harmonics.
So the mnemonics of the movement of the pumps can be monitored. So you can tell if bearings are going bad, or if something else is going wrong by, basically putting a specialized, microphone type instrument up to it, which is just wild, But
Yeah,
it's all keeping things moving.
I'll
yeah,
be
and
right.
I guess from my experience too, right? Coming from my sandrail, you can also tell by the noise and the heat that they're producing. So,
Yes.
so the noise, right? So I noticed when I was riding, I could hear kind of like a tumble, like a rough tumble, like a almost like a growl coming from there. And when I stopped, I went to go touch my hub where the bearing was seated, and it was hot, right? Because it lost the battle to friction. It was no longer having that coefficient of friction, that low coefficient of friction that we wanted, right? And it was
Mhm.
like hot to the touch, and it was actually starting to not necessarily melt, but um, it was starting to boil off some of the grease that was there. That's how hot it was getting. So that's one way that you can know. But using harmonics like with heavy machinery, it's a big field, and it is super interesting of understanding how machines sound and using that in a scientific way to determine what the lifespan is or if there's an issue. It is really incredible.
It has all sorts of cool mechanisms on how to have things not fail, you know?
And
Like,
I and
Detect
I
it
think,
before it
with
fails.
this discussion too, we're talking about bearings and how they work, right? I think we're leaving out a pretty critical component, and that's a lubricant. Uh, Industrial bearings, at least most of the time, they act with the front. They act with the fluid film to further reduce that viscosity and prevent wear. So oils and greases, that's critical. That is a bearing's best friend. And I think that it deserves a mention because that's a whole discussion on itself, is how these different lubricants work and how the mechanism is that it produces, it reduces friction in between the balls that are rolling, right?
Yeah.
These ball bearings, they don't exist in a vacuum. They exist in the system, and I think give a shout out to all the greases and oils in the world that make that happen.
Shout out to the greasy, the greasers.
Yeah,
The petroleum.
grease and
Greasy.
oil
Greasy
is
people.
is very important. I don't know if you guys have ever like changed a ball bearing, but packing
Yes.
it is almost like a religious act. Like you want to make sure you
Do
don't
you
get.
worship it? Like
I
You do
God?
not want to contaminate the grease.
Yes, you don't want to contaminate it, and you want to make sure that you have enough there.
Because
But
like
not
the
too much.
chemistry, which I don't know, but it's all like how it reacts with metals is just crazy. Because it's just like there's a chemical reaction going on too when it's moving. There's heat
Well, yeah,
going, and the liquid is moving around, and it's crazy.
And you have a lot of pressure and some friction. And
And
it gets
temperature
heated
is
up.
always gonna it's always gonna be a factor. Temperature is always gonna be a factor whenever you're dealing with something mechanical. So you gotta factor that in, and the ability to reduce the friction, and also not like be
Break.
not break down or
Attack the metal.
Yes.
which is that gets very tricky, especially with if you're dealing with organic molecules that have a lot of contaminants. That's why a lot of places I would imagine are moving towards synthetically made compounds. They can control the contaminants a little bit better than if they use oil that is extracted out of the ground. So
Mm-hmm. Oh, that's very true. I think unless the host disagrees, I think that's a nice segue into how these little bearings can fail.
I couldn't agree more. So let's get into it. Recap. So we know the first ball bearings were made out of wood. I imagine nowadays.
well, they were kind of more. Those would be more of roller bearings.
That's
but
true,
the
but they are
principle's
Yeah.
been around for a while.
they're considered primitive ball bearings. They
Yes.
are considered primitive ball bearings, so we're talking about them. And like I said, the Roman one was an actual ball, a ball of wood that they had in a rotating table. So they did both with the wood. They made them into spheres like a ball bearing nowadays, and well, the roller bearing is what we've come to know.
I think that I was just gonna say one of the really cool things about ball bearings is like we although the concept has been around for a long time, it also took a very long time to be able to use a ball in these bearings, right?
Mm-hmm.
I mean, the roller concept has been around for forever, and even Thomas Jefferson had it in his fancy revolving chair, which is kind of a little side note. Sorry, I'm not really sorry because the
That guy
audience
was a dick.
the audience has no bearing on what I bring up. Anyway, so Thomas Jefferson.
You know,
wasn't. It
you
wasn't
had
until the
you had a lot of
18
balls to bring a joke like that onto this show.
it wasn't. Well, it wasn't. No, it wasn't until the 1800s where someone actually
So
and
the
successfully
first,
got a
it was like
ball bearing created.
1795 or something. Like the first patent for it comes from like some Welsh ironworker named Philip Vaughan.
Yeah, it is fair to bring
but the
up
more
though that
accurate model comes later than that. Like that was like the first patent. The first patent that's like reminiscent of the shit we use today comes later on after that.
yeah. It is fair to bring up, though, that Leonardo da Vinci did have a concept for a ball bearing for his helicopter. but I don't think he ever made that. So
The helicopters have to have ball bearings in them, right? Yeah.
absolutely,
Yeah, so he was
anything
right.
that rotates.
He was right.
So yeah, he had a pretty good concept, and then some dude that dude that you mentioned in the 1800s started actually being able to make a workable thing that kind of was starting to get broad spread. I mean that I'm sure that certainly helped things like the Industrial Revolution there.
Yeah,
So,
well, we'll talk about
and
it. We'll
industry in
talk about
general.
it later when I get into the business aspect and how much money the industry makes per year. But that's the manufacturing industry is like the biggest contributor to the net worth of the ball bearing industry. Just because a lot of manufacturing tools, robots, you name it, assembly lines all are using ball bearings to achieve their means. But
Mm-hmm.
the first ball bearings were wood. They obviously moved on to primitive iron, like shitty pig iron back in the day, like not a good alloy of iron. We're talking about something that really is non-comparable to today's standards. So what after that? Obviously that we learned how to, make steel and better alloys of iron and other things. What are modern day ball bearings made of?
So yeah, I can pull on that thread a little bit. So just to mention, right, ball bearings are technically made out of a wide variety of materials even today. There are plastic ball bearings. I'm assuming they're used for pretty low load applications, right? That don't need a long longevity. But so then you have your metal bearings and you also have ceramic bearings. I have heard a little bit about ceramic bearings, right? So what's cool about ceramic bearings, it being a ceramic, is they can withstand high temperatures. So
Yeah.
that's just one important thing to note, like very high
Well,
temperatures.
and that's like the whole problem, right? Because with all that rotation, obviously anything that has a ball bearing in it is going to heat up.
Yeah,
Especially,
but overwhelmingly, especially in the industrial sector, they
right.
are steel. And not just steel, they're specifically 52-100 bearing steel. So there's actually it's actually called bearing steel, and there's some different grades within this. And
So, what separates this from like your bare bones steel? What makes this steel different?
well, it's all about composition, right? So, at least from the brief amount of research is able to do, right? Bearing steels, right? So let's think about what a ball bearing needs to be first, right? It needs to be strong and it needs to be wear resistant. That's like its primary function. And 52-100 steel is able to do this by it's got a quite a high carbon content, which allows it to be hardened and get that some of that wear resistance. And it generally has a pretty high amount of chromium as well. Chromium can suit a lot of functions within steel, but notably, it increases strength. It changes the heat treatment properties, as well as providing amount of corrosion resistance. So that's important to note because if a ball bearing system corrodes, any pits that form creates an increased amount of friction, and then an increased amount of friction is basically the death bell to the ball bearing itself, right? So that's really important to know. um so yeah, in terms of ball bearings themselves, is they have a really high hardness, especially surface hardness, right, of around 64 HRC. And to put that in perspective, if you think of a standard like automotive bolt that you'd find in your car, that's most likely around like 35 HRC, right?
What's
Where
HRC?
that's a measure of hardness.
Yeah,
That's a
hang
measure
on.
of
Adam
hardness.
Clinton.
So it's a measure of hardness, and it can be correlated to strength, right?
Damage Slurple.
Oh, look. I mean, a JH. JH hopped on.
Hello.
Hello, JH.
Hello.
Howdy.
We're talking
We're
about
talking
ball
about
bearing.
ball bearings.
So
Hell yeah.
so to get back into the hardness, right? So if you think of a normal bolt being 35, right? That balances toughness with strength pretty well, right? It's a good balance. But when you're looking at a wear application like a ball bearing where it's seeing hundreds of thousands or millions of revolutions, you need wear resistance. And that's where the high carbon content, as well as some of the chromium that helps out, comes into play. So in terms of material, this is vastly different than the wooden ball bearings that the Romans might have made. We can see a system that can see higher loads and longer runtime than ever before. And that this is what really a lot of the world literally rolls on, is this type of steel. And that's pretty impressive.
So today, is this like one of the most advanced types of steel that exist?
I'm not going to say that. There's steel. I mean, that's a whole episode in itself. Steel is one of the most versatile materials that humanity has ever created, and it might be one of the most important materials of all time. There are so many different types of steel. I won't even go into that. You know what ball bearing steel is, or bearing steel? It's it's a high alloy content. And it's heat treatable, and that provides us with very specific properties that would work in this application. Now, would the steel work as, say, in something that's like an A-arm that's seeing shock loading? Not necessarily, because with that high hardness comes a brittle behavior.
Yeah.
Exactly. But in terms of wear resistance, yeah, that's where this is really coming into play.
So then let's talk about how the shit fails.
Okay, so
like obviously, like we were saying earlier, when ball bearings fail, especially on an industrial level, it's rather catastrophic, right?
It can be, right? A lot of times, right? So the worst scenario would be that you fail the ball bearing so bad that the shaft starts to displace, and then it starts eating through the housing that the ball bearing is sitting in, because that causes more damage. In reality, because of like the noise level as well as the heat, they're normally caught where the ball bearing is failing just within the system itself, which is good. So then you can just replace that component. It's not necessarily an easy replacement, but you can at least replace that with replacing other parts of the system. In terms of how they fail, like from a lab standpoint, if you will, there are two different main mechanisms. There's really three, but there's two main mechanisms, and that's adhesive wear, and then that's abrasive wear.
Yeah, go ahead. I was just thinking, like, adhesive, it would be like gaining like heat or something. Like, doesn't that mean like adhesive? The root of the word means to attach.
Yeah, no. So you're right. There is the root of the word means attach. So adhesive wear is where you have two components of the system. Let's just say you have the ball itself and you have the race that it's rolling on, right? Adhesive wear is when the loads or the friction gets high enough where they start to basically stick to one another, and that creates wear, where one material smears into the other. So this can occur on multiple different scales. You can actually have like micro welding, where like you'd need to have a scanning electron microscope to see, where the forces and the pressures and the heat is so high that in very small instances they actually weld together, causing this micro welding phenomenon.
Oh,
on a more macroscopic scale,
that's interesting.
If you have a ton of this adhesive wear, you basically see the transfer of one material onto the other. So you can actually
like
see
the
smears.
steel, right? So like the material from the ball bearing would be showing up on the row that it's on or whatever.
Yeah, a lot of time it could be vice versa too, but yeah, that's a general standpoint.
Yeah,
one substrate is transferring material to the other. And this can happen in scenarios where lubrication fails. So you don't have enough grease, or the grease is breaking down, or it's not being oiled properly. You can get that heat build up locally, and the friction and the shear forces, you get that transfer of material, which that creates kind of a feedback loop in which you increase the friction, which causes more adhesive wear, and then you go on and on and on until failure. So that's the very common failure mode for these ball bearings.
So is this adhesive wear is the most common for ball bearings?
I want to say it's the most common, because then you have abrasive wear. right?
Oh, okay.
So abrasive wear is when you get some type of foreign particle basically invited to the party that's not invited to. And I mean, think about this. Like, imagine if you have this really this system that's designed with really tight tolerances, right? And you have high loads and everything's rolling around, and then you throw a piece of grit in there, a piece of sand, a piece of metal, anything.
Dust.
That dust, the hardness of
Well-
dust in comparison to, I mean, maybe, yeah, depends how hard the particle is. I
Maybe.
think it, yeah, exactly.
Yeah.
Like, if you're talking skin cells, no. If you're talking dust for like metallic dust from a manufacturing environment, maybe.
I was thinking like sawdust or like a piece of drywall dust or something.
Well,
Mhm.
drywall dust, maybe. Sawdust, most likely not, just due to the hardness of the material. So imagine you have some type of foreign entity in there. Essentially, what happens is it gets crushed in between these two moving components, and it can score the material. It can it can cut it, it can create a scratch. And then basically, that scratch, it creates a different friction profile. So as it's rolling along, it's loaded more heavy. Well, not necessarily loaded, but there's a higher friction in that one point, and then that can spiral into other failures as well. That's why when you change your bearings, say in your car, you have to make sure everything's very clean. Everything must be very clean. So those are the two main types. But if you'd like, I can elaborate further on some other things here.
Yeah, well, you did mention a type 3.
Yeah, so there's actually a type 4 now I'm thinking about it. So type
Oh,
3 is
geez.
called
So let's recap. Type 1 is adhesive wear, right?
Yep.
Type 2 is abrasive.
Yep.
And the difference is adhesive is pretty much a failure of interaction between the ball bearing and the medium that the ball bearing's in which the materials can wear on each other, pretty much imprint on each other, causing further failure, right?
Yes. Yep.
All right, well, and we got adhesive, which foreign particle enters and fucks it up.
Yeah, pretty much. Yeah, that's
all right. So let's get on to 3 and 4 because I'm interested. I need to hear it now.
Okay, so there is one called Brunelling. So just to back up,
can you say
guys
that
know
again?
Brunel. It's a last name, I believe. So just to back it up, so a Brunel test is a way to measure hardness in the metallurgy world. You essentially take a ball bearing, literally, and you take a set diameter of a ball bearing, and you take a set load, and you imprint it on the material, and then you measure the diameter of the imprint it makes. So harder materials will make less of an imprint. Softer materials will make more of an imprint. So that's called Brunelling. So it makes this spherical dent in the material.
Right, you're squishing it like Play-Doh to see what happens.
Yeah, pretty much. So in a ball bearing specifically, you can get a Brunelling effect where, say, if there is like a really excessive load, especially radially, that one of those balls can dig into the race or into whatever's the outside of the bearing, and that causes a dent, for lack of a better term, that would then increase friction and cause very rapid failure of the bearing.
Right, you pretty much give the ball bearings a pothole to run over on their track.
Absolutely. It's a geometric deficiency, and with a system that's designed so tightly, that can lead to a lot of problems. And that's indicative.
Oh yeah, because it's not the initial damage on any of these. It's the consistent use. That one little defect becomes amplified every time a rotation goes around, and it's constantly rotating, and then it ultimately fails.
And when it's rotating as fast as a lot of these ball bearings systems do, it fails pretty quick. So Brunelling really happens if there's like a significant overload event, like something's fucked, like you hit a huge pothole or something.
It sounds like to me it's like an exterior pressure onto the ball bearing mechanism for this one. Like you have to have some other force to cause this sort of squishing effect on.
Yep, absolutely. Like imagine, say, if you're driving your car and you have your wheel bearing and you hit a object going quite fast, right? That's going to create a load that could be strong enough to create that pothole, as you mentioned, in that bearing, and really cause failure quickly. So yeah, and moving on, right? We have we have a different kind of failure, and I'm going to split this up into two. So you have micro pitting and spalling, and they're slightly different. The the in terms of how they're described, sometimes they're described the same way, but in general, for what I've seen, is micro pitting. It's basically you have very small pits that form on the surface. We're talking like 10 to 20 microns. And with micro pitting, some people claim that's more from like a chemical attack. Like, say, if you have grease that is contaminated, like with chlorine or.
But you said they claim. Is this like more of a theory or a set thing?
No, it's not a theory. It's more about like how it's called, right? Some people use like micro pitting to frame both of these ideas I'm about to describe. Other people use the term spalling, which I'll describe. It's kind of some people use them interchangeably, but I'm going to make the distinction here just because it's easier for my understanding.
Okay.
So micro pitting, that comes from some type of corrosive agent in the system that basically eats away and makes these small pits all over the ball.
So this is like abrasive, but with a chemical wear, pretty much.
I wouldn't really call it abrasive, but basically the chemicals eating away at the metal. Imagine if you have some type of corrosive agent, let's just say road salt or something, that gets in and it starts forming these little micro pits, and it actually can give the ball bearing like a matte finish instead of a shiny finish, because these ball bearings they have to be very smooth for that to that low coefficient of friction. And then that can cause additional frictional wear, and then it leads to the other failure mechanisms that I mentioned, right? I think the most interesting form of failure is actually called spalling. And spalling is when you have a phenomenon called fatigue, when things are loaded at a certain stress level and they generate cracks into the material.
Wait. So to get the stress level, wouldn't you have like a foreign force, or is it just from the force? It could be just the force of the ball bearing doing its thing.
Yes, it could be. I mean, if the system was designed right, you would design it where fatigue wouldn't occur, right? There is ways to do that depending on the load level. But if that ball bearing is seeing loads where is enough for fatigue to occur in that system, you can get spalling. And basically what spalling is you get these micro pits, but it's from fatigue initiating and causing little fractures that then basically pop out chunks of the material, for lack of a better term.
So like literally like chipping out chunks, and then those chunks end up in the track of the ball bearing?
Absolutely. Those chunks can end up in the track, and then the ball bearing itself, the load profile changes because it's losing material on the surface. And then that can lead to, like abrasive or possibly adhesive wear further on down the line. And I've seen instances of I haven't done the report myself, but I've seen spalling before in different reports, as well as abrasive wear, like particles getting like embedded or like cutting away parts of the material, which is super interesting, right? So that's like the main ways and how they fail. There could be other failure mechanisms, right? That's just the ones that I know of.
I think that's super interesting.
How long do bearings usually last?
I feel like that's loaded, right? It depends on the load conditions. It depends on the alignment. It depends on the lubrication of the system. I think that's entirely up to how the system's designed. I feel like you could design ball bearings that last an extraordinarily long time. You could design those that last not that long at all. It really depends on the use case.
It also seems like it depends on the material used.
Certainly.
I mean, obviously, I don't think these wood ball bearings back in the day lasted long.
No,
for whatever they're doing.
They're also not rotating it a billion times a second.
Exactly. So they served a purpose that was functional, right? But even at that functional purpose, they probably did not last. I mean, to the standard that we know things last today is what I'm saying.
Well,
incomparable.
And with wood, I mean, I was just thinking about this. Wood itself is what we call anisotropic. So in different directions, the material properties are different because you have the grain of the wood, right? So if you cut against the grain or with the grain, we all
Yes.
know that it feels different, right?
Just for the layman, this is why it's easy to whittle a stick, but hard to cut a stick in half with a knife if you were just sawing straight horizontal down on the stick. Same premise. Cutting with the grain is going to shave that shit to bits, make a spear in 2 fucking seconds. Cutting through a fucking stick, you're going to get pissed off and cut off your own goddamn finger.
So,
It's also the load.
Yeah.
Yep.
The way it handles the load.
Exactly. That's exactly the point, right? So like these ball bearings, even if they made them spherical, the material itself is not behaving the same in every direction, which I would assume would lead to failure among a lot of other things. I don't think you could get wood to the same surface finish or polish that you could, say, metal or ceramic. But that's just something to mention because metals and ceramics overwhelmingly are isotropic.
As that wood ball spins, it's gonna take load on a part of the wood that's not ideal for it.
I'm thinking like, how would you make ball bearings with primitive technology? So you would have to like marble quartz and like make them perfectly round somehow.
So quartz has a hardness of 7. Quartz is pretty good. The quartz would be a good. And it would be
something like some kind of stone.
You have to make it stone, you'd have to make it lubricated.
What about glass?
Glass,
technically could.
Glass is quartz. Glass has the same hardness, right?
So the problem that you could run into, right? Like for sure, hardness and wear resistance, that's key. But it's also like toughness. Like how easy does this fracture? So glass, right? If it saw a shock load, that's game over. But in terms of wear resistance and whatnot, it could be really good. In terms of how they would even make that, it would be a lot of polishing, and I don't even want to think or know how the fuck that would happen.
I mean, have you guys ever looked at before we get to Anonymous Podcaster number 3? Have you guys ever looked at fucking like? You're just in like a history museum or whatever, and they have like a perfect sphere of like a rock or something, and that has to do with what we're talking about, right? That's a ball. Like the amount of human effort that went into making that, I don't even want to think about. It's probably sick, and that's just one single sphere. And realistically, all these mechanisms have a bunch of balls in them.
Well, it's because of like how we have precision, like high precision machinery to cut these things.
Right, but I'm saying back in the day, dude. Like back in the day, that's absurd. Like
even more than that, it's not just about even more than the getting things smooth enough.
Yes,
you have to get the right dimensions on things, because if you're trying to make a ball bearing and one is slightly larger or smaller than the other one, it's going to throw off your entire assembly. It's not just about the smoothness or the shape, it's about the relative size. And that's probably why it took so long to make an actual, an actual ball bearing.
Like a real ball bearing.
Because of those tolerances.
Well, with
I'm
the real
curious
ball
to make like not fault tolerance, but like safe replication, like kind of like you make the bearings where some parts could fail. Root cause analysis on how a ball bearing fails if it fails so fast. Because like if a chain of event, like because I've seen like some complicated ball bearings that have like multiple things going on, but I don't know. I might be having a bit too much to drink, and I'm not thinking that straight.
No,
well, they do have like combinations of like ball, roller, and like pin.
Yeah, yes.
Different. You can have layers.
Yes.
So you have more axial load.
I'm sure someone in the audience is screaming. It's like, these guys are stupid.
Again, but we don't care about that.
I didn't know this existed until like 2 hours ago. In my head, they were little metal marbles. And when I Googled ball bearings to do my part before coming on here, imagine my shock when I get shown some Tony Stark arc reactor looking thing. I'm like, this isn't a marble. What the hell am I looking at?
Yeah, but it's just fascinating, like the amount of shit that goes into ball bearings and how critical it is and how
It is the
we just overlook it. And
is
the
it a stretch to say it is the foundation of industrial society throughout the world?
yeah, because like even machinery, like to make high precision machinery, you would have to have those bearings.
Everything
like,
has ball
rely
bearings
on
in
bearings
it.
themselves.
Our
yeah.
I think industrial society led to being able to do this on a mass scale as opposed to the other way around.
That would
Yeah.
make sense too. Either way, ball bearings are extremely important to the lives we live in this world.
I feel like when I was looking this up, I felt like a kid realizing bacteria exist and they're all around me and there's nothing I can do about it.
Absolutely.
There's bearings in everything.
It has a bearing on everything you do.
Anyway, I want to throw out some quick.
Really is, though.
I want to throw out some stats for you guys in the audience about the ball bearing market globally. And what I found most interesting about looking up these stats is I took from like 8 different sources, and every source was different. Every source was different, except for all sources pretty much claimed that the ball bearing market would double in value from here 2025 to 2032. The market will be double.
Let's look up some companies that make bearings and invest
most
in
of them are in India.
Oh, interesting.
Yes, like the top 5 ball bearing companies are Indian owned and made in India.
So I have, that's
more people are going to be buying nest chairs. Need more asses and more seats. Need more ball bearings.
The next time you go on Robinhood, make sure you invest in your local ball bearing company.
Let's try to be local, yeah.
And I do want to throw out there that in general, ball bearings are pretty difficult to make. So not only do you need to get the heat treatment process correct, as well as the grinding and polishing steps, but the overall dimensions and assembly is absolutely critical. So shout out to the companies that make these things because it's really intense. And it really decides if a system's going to fail or work.
Well, yes. Yeah, and that's true. And I think the most fascinating part is like how they're able to measure the molds to a degree that they're even able to do this on a mass scale. You know what I mean? Like they obviously are pouring these metals into molds to make the original shape. And then they're trying not to polish off too much of the material when they're doing it. It's crazy to me. Crazy to me.
And they have microscopes that can like get down to a few microns and they go by touch and stuff.
Yeah. No, so yeah, I think you're talking about atomic force microscopy. They literally go by touch. It's pretty incredible.
That's I don't even want to think about that. That's fucking insane. They're literally like a record player. Small by fucking touch.
They work like a record player. I mean, there's multiple ways to work.
I know what you're talking about too.
Yeah, what I saw was like a jelly pen, and then like you press it into the gel, and then the deformation of the gel shows you a picture later.
Yeah. You know what I also find it kind of interesting about ball bearings. I don't mean to change the subject, is that nature probably doesn't have something like that. And I'm talking about even like cellular level, because like they don't really necessarily like. There's joints there. I don't know if there's things that like birds or something have like a drill or anything like that, but
every muscle, even in bugs, they work off contraction, right? Every part that's moved is worked off contraction, and there's no. I guess what you said, the joints might be the closest thing to nature that a ball bearing has. But it's still not rotation. It's not. Yeah. You're right. It's not rotation. But I think it's the closest thing, the closest example you could give.
The only thing is like a flagella is just a stationary like tail that like flings around and rotates, but it doesn't like. It's not on It doesn't spin.
There is rotation in nature, but it's so incredibly rare, and because. It has to be essentially, if you're trying to have a ball bearing or something like it, it has to be basically detached, right?
Here's a question.
That's not going to happen in nature.
Here's a question.
There's nothing decoupled in nature, yeah.
Right.
Here's the question
as far as I know.
We're going to end the show after this question. We're going to go around and hear everybody's answer from this question because I think it's the most fantastic question I've ever asked. For the most anticipated show of 2025, I ask you guys this. Do you guys think in our solar system that the planets themselves act as ball bearings
No.
for the
No.
universe to spin?
Hard no.
Just no.
Hard no.
No,
Hard no.
They're
that
not the
because
same size, so they
gravity
wouldn't be doing a very good job.
Oh, you guys are
gravity
no
throws
fun.
it off.
It was a thought experiment,
Yeah.
guys. You guys aren't
Better
even
thoughts.
having had any fun with that.
You thought wrong.
I thought wrong. I didn't actually believe
But
that.
that-
I was
that
just
is an interesting-
asking.
no,
I was just
That is
asking.
interesting.
It is.
That is interesting.
stage, Doctor Who.
Yeah, Jesus. Anyway, I'm a terrible host. I want to go around and get everybody's final thoughts on ball bearings. Pie Monger, you can start.
I mean, especially going on this journey and doing a very limited amount of research, right? But with my own experience, ball bearings are critical and they're actually really, really interesting, especially from a metallurgy and failure standpoint. And if we didn't have them, we wouldn't have most of the things we have currently. And that's something to think about.
Yeah.
Absolutely.
Or we'd be spending a lot more time fixing things we take for granted.
That's true.
Ball bearings are one of those things that, it's like Schlermpel mentioned earlier, that they're everywhere and they're absolutely necessary to make things function. Every time you turn on a light switch and electricity comes on, that's only, for most people, that's only possible because of, ball bearings and a turbine somewhere.
See, it's
every time
only
you hop in the
possible for
car
me because
or
I
on the bike.
take a pair of jumper cables and I cut into my neighbor's power line and
There
I
you
run
go.
it back to my house.
That's the way. But seriously, even that power, though, again, most likely is coming from a turbine. And then every time you turn on your tap, all that water has to get pumped somehow, and a lot of that pumping action needs, the rotation to be, have less friction in it, and all sorts of different things. Every time you hop in the car, it's all connected to that.
When you want to poison
piece of
somebody in a
technology.
Princess's Bride situation, spinning table, ball bearing.
That's exactly. Yes. Lazy Susans. Very important. Every time you've used a Lazy Susan, it needs to have some sort of ball bearing. So never forget.
JH, you got any comments?
Nah, I just came here to listen.
Hell yeah, brother.
We just
History, Anonymous Podcaster number 3, do you have any other comments on the matter?
nope. Ball bearings are cool. Very important. Glad we have them. Glad smart people figured it out.
Slurmpball, you are the guest of tonight. Do you have any last comments?
I'm just reeling from the fact that there's like little mini arc reactors and everything we use, and I didn't know until now.
Yeah, I can never go back to looking to life the same way again. I didn't know much about ball bearings, to be honest. I feel like I got a pretty good, solid understanding now.
I could feel my brain stretching.
Yeah, I feel good. Big brain.
Learn something.
Ramasta.
I thought, this started because I thought, oh, what's the most silly, irrelevant topic I can think of? But I was wrong.
But it ended up being the most relevant topic to humanity, pretty much. Because there's nothing... Ball bearings in everyone's life. Everybody benefits from ball bearings every single day. And human society would not be the same without ball bearings.
Absolutely.
I think it makes. I think we could define our era by the invention of ball bearings.
Honestly, right? You
Yeah.
really could. Because not even modern day computers would be possible without ball bearings.
A lot of things would not be possible. Yeah.
Mm-hmm.
Well, I'll give you my last comment here. I know it's an unpopular opinion, but I firmly believe in the flat earth and that the the other planets in the solar system are ball bearings for the universe to work.
You know, we were all on a roll, and then you ruined it.
Yep.
Well, that's just kicking the can down the road. If we're all in a big ball bearing, what ball bearing are we bearing in?
Yeah.
Holy shit.
What cosmic device are we wearing the tear out of?
Oh
Hey, you know
my.
what? Are we even needed? Because there's no friction in space. Not really. I don't know if that's
Anyway,
true. That doesn't sound true, but whatever. It's fine.
It's
we
fine.
don't. I feel like we don't know anything about space, realistically.
No, that was a fun podcast for.
That
And
was
we
a
would
good-
know less about our oceans.
That's true.
No, yeah. We all
Oceans,
know a little
ocean.
bit more, kind of, sort of, about ball bearings though tonight. So that's a good
Yes.
thing.
I actually, well, this is based in fact. We talked about facts. We talked about really the essence of humanity comes down to ball bearings. As we currently know it, nothing would have been possible without ball bearings that
I
we
wouldn't
know
exactly
today.
co-sign that, but
We don't have to co-sign anything because this is dark and delusional.
that's right. We're
We're done.
delusional.
We're done for tonight. As
Bye.
always, don't like, don't subscribe, don't comment.
Yeah, we don't want to hear it.
Honestly, we're pretty outrageous. Just stop looking at these videos. I pretty much use YouTube as a cloud. I'm just too lazy to pay for more storage space. And it's really annoying people keep watching these videos.
Yeah, I mean, you know, like if someone's made it this far in the, you know, in the podcast, like wow.
Yeah. Now this is supposed to be a quiet front for all our various drug rings, and you're all fucking this up for us.
Dude, this is how I tell my dealer to land at the airport or not. Bringing too much heat to this channel here.
I mean, I have to disagree with Anonymous podcast number 3. I think people would like to hear you too. I think the previous one that you did, a lot of people liked it.
Oh, Sir Francis Drake is going great.
Yes.
That was
yes.
a wild story.
That was a wild story. But we have a lot more wild shit to come. Good, better things. You know?
Okay, I think that's a wrap.
That's a wrap. All right, yeah. How many times are we gonna end this podcast?
Oh, the guys, that'll
Yeah, you're the host.
that'll all get cut out. I already ended it. I'm
Cue the
gonna
exit
stop.
music.
Hang on.
Yeah,
Hey, we already said it in the episode, but this is a more stern reminder to don't like, don't subscribe, don't leave comments, don't pay us any mind. And if your day sucked today, I hope it doesn't suck tomorrow.